Right, so back to everyone's favorite things is some random integrals getting done. I'm going to do these non-sarcastically, and I only say that because in my last video, a few people didn't pick up on the fact that I was being sarcastic the entire way through, which is my fault. I'm not blaming them at all. It's my fault for not being sarcastic enough or not being good enough at sarcasm. But today I'm just going to be doing some integrals in the normal way. So we'll bang out the random number. Of course, I've got my formula book open on another tab. So hopefully that'll be very helpful to us. The first one is 307. So we will do 307, which looks to be a nice little warm up. I say that. I mean, firstly, oh, what is that fraction there, mate? What is that either? This. Sorry, it's been a few days since I actually put maths into PowerPoint. And you'll see the effects of that. That's not a one. That is a one there. And I also just can't remember the integral anyway. This is finally it. Okay. This looks like something we can just mess around with until we end up with um, like what I mean is if I just make that a 3 minus 1, then what else do I need? Well, I need a minus x and I need a plus 2, I guess. And what I'm saying is I could maybe break this up now, kind of down the middle, to make it into two fractions. So if I just do this, I could do it this, and then with x minus 1, and then the thing on top remains the same, except it doesn't. That needs to be a minus as well. Um, and then we could wonder, has that actually helped? Well, it's helped a little bit, right? It's helped a little bit because this is just a one which integrates nicely. This still doesn't really work that well, which is disappointing. Um, I can't see why doing that again would be helpful. I think if you do it again, you just end up with the thing that you had before, which is interesting. So yeah, I don't think doing that again is helpful. So now we look at this business here and we think, well, okay, what do we actually do with this? We could break it up twice, right? We could break it up twice for sure, which is maybe what I should have done like right at the start. So this is this, and this is actually going to be a plus two, right? And the two of three of these integrals, two out of three, I should say, of these integrals is very easy. In fact, I should have just done this right at the start. I don't know why. I'm just going to delete the whole thing. No, am I? Let's just do it this way. We've started, so we'll finish. So this is obviously one. Um, so that's fine. This is easy to integrate. This is less easy to integrate. However, it shouldn't be too bad. We should have strategies for this, I would imagine. I'm just trying to think what they are. Um, I mean, parts seems like a terrible idea. I mean, it doesn't seem like a terrible idea. It seems like it would absolutely work, but it also seems like an outrageously over the top idea to try. Um, But what else do we even do in this case? Make a substitution? Yeah, make a substitution. I think that would be easier. So let's make u equal 3x minus 1. This is, so obviously du is 3 dx, which is fine because that will just get rid of this. So hang on. Let's just do the integral. So the first term is x, and the second term, which I'll just say is this, is what, 3 over 2 log 3x minus 1? Is that right? It's probably not right. The 3 comes out, it's upside down. Moron. So this. Okay, so that's fine. And then the third term, we're going to have to create from this bad boy. So the integral is if we're just imagining this integral is this. We've now got that x is u plus 1 over 3, which I can just put here. And then this is a u, obviously. In fact, I'm being a complete muppet. If you just substitute right at the start, this just works. I'm just a moron. Like of large levels of magnitude. This is quite an embarrassing integral to put on the screen, just because I've done it in such a stupid way. Now we can do the whole breaking up business, just because, yeah, this was just really dumb all the way through. Anyway, the integral is the first thing is 1, so that integrates to a u, and then the second thing integrates obviously to log u, and then I guess you have the ninth outside both. And then we can put the u's back in. So u is so it's plus, and then this is 3x minus 1. This was really dumb. I'm annoyed at myself for doing all of this when yeah, I mean, this is the answer. I haven't simplified it anyway, and I'm going to leave that integral alone because I'm straight up ashamed of myself that that took so long. Anyway, we'll go to the next integral. That was It's late in the day, it's nearly 6 o'clock. I it's way past my bedtime. Was that even the number that came up? No, it wasn't. Amazing. How does the integral look? Oh, it looks actually quite fun. Anyway, no, 175 was the integral that actually came up. So let's do this. We'll just delete this. I don't want to see it again. We'll just delete that. So, okay, what was the integral? It was x squared over root x minus 1. Oh, nope. It's kind of annoying the PowerPoint does that. Let's just double check that this is right. It is. Cool. Okay, what about this integral then? So, what should we do? No, the substitution doesn't really work. We could do parts. So if you said it was like x squared into this, the minus a half, you could think about differentiating the x squared bit to get it lower and integrating the other bit, which I can't see any reason why that wouldn't work at the moment, because x minus 1 is just a very nice term to deal with. So, I mean, it's going to be an annoying way of doing this, but anyway, integrate this one is just x minus 1 to the power positive a half with a 2 in front. And I'm going to copy that because I'm going to need it twice, of course. And then you leave the x squared alone for the first one. Then you take away the integral, and then we're going to put that same thing again and differentiate that for a 2x. So I can measure sort of 4 here, and then x. And we may as well do that again, just because it's totally going to work. So if I do this, and then we integrate that one for x minus 1 to the 3 over 2, and there'll be a 2/3 in front of that, along with the x, of course, that we're leaving alone. Apologies if you're not following what I'm doing, because you've learned integration by parts in a different way to this, but I don't really care. And then minus integral of, again, we'll take this term because we need it again, with the 2/3 in front, which I may as well just put over here. And then we differentiate the x for a 1, and we get this, and then we can just integrate one more time. There should be a dx at the end of these, which I know everyone understands, but I'm just going to write anyway. And then we'll just do that one more time, and we'll end up with the answer, I think. So actually, I imagine there were much cleaner ways of integrating this, but again, at this very moment in time, I don't really care. We'll end up with this, and then the integral sign goes away, of course. I'm not going to expand out any of that. We'll get the answer there. Cool, so that's that one done. Let's do, because it hasn't been very long, let's do another one. Probably much nicer ways of doing that. Write in the comments, I guess, if you found a way that's far superior to, slamming your head against a wall and doing integration by parts twice. This looks quite cool. Got absolutely no hope of remembering it at all. But let's go for it. I'll show you the bit I can remember. I can remember that. What actually came after that? 2 cos x minus 3 all squared. 2 cos x minus 3 all squared, and then of course dx. Good. Let's see what we get. Okay, so what is going on here? Okay, thoughts. We could, of course, make a substitution. U equals cos x. That seems like it's not going to go amazingly well, just because we'll end up with a sine x. I can't see how that would. Ooh, but then you'd have a derivative of a thing, would you not? Or would it be? I'm just wondering whether that makes it. I don't think this does work, right? I think I'm just overlooking it. But if you do end up with, yeah, because you end up with a division of sine x, which is not very helpful. Yeah, I was hoping I'd get it, but no, that's completely useless. Okay, cool. Now we could. I mean, you could make the substitution. Could you make this? Well, like what I'm thinking is, if this was just cos x, I can integrate cos squared x. Right, that's not hard. But all this is a linear transformation to get there, right? So could you not just make the substitution to make that be what it is? And I'm not even convinced. So if you just said this, oh, where is my equal sign? 2 cos x minus 3. If you just did that, then, but does this work? I've never really tried anything like this before. You end up with a sine u du. Like it doesn't really work, right? Equals 2 sine x dx. Oof, what is that? 2 sine x, 2 sine x dx. That doesn't really achieve what I wanted it to achieve, right? So that seems That seems not good. Like it doesn't work to put it to put it in a technical sense. It doesn't work. And I'm just wondering whether there was a nice way of doing that. Was there a nice way of doing that? Probably not. I mean, this is what I was talking about earlier, right? But you end up with this division of sine x, which doesn't seem uh, very helpful. You'd end up with something like u squared over like something of the form root minus u squared, which maybe that's helpful. It doesn't seem. What number was this? I know that's cheating. It doesn't seem like that would be the obvious way of doing this at all. And you're just being a complete moron. What are you doing? What on earth, you absolute. Did, did you think maybe that if you just expanded it, because you've already made the claim, you absolute moron, that you because this is hard, isn't it? Absolute muppet. Okay, so I, I'm I didn't think I could be more ashamed of myself after that first integral, but after that, look, listen, I've had a half. It's been a great half term. I've played a lot of video games, and I haven't done that. I haven't done an immense amount of maths. I've done some maths. I've had to do that exam that I talked about in the previous video, but I haven't done that much maths. I am embarrassed about this performance, by the way, just so we're saying. But we all have bad days, that's fine. We all have bad days. Not a problem. Did we not previously talk about what cos squared was somewhere? We probably didn't. Did we? I don't know. I can't remember. No, I think that was in the exam I was doing. So cos squared of x. Should we do this the interesting way, or should we just do it? Should we just do it? I mean, on the basis of just how bad my integrating has been today, um, I think I should probably just do this the standard way because otherwise I won't get it right, I think is what I'm probably going to say here. So this is this, which means a 2 here with a -1 here works because it's, yeah. And then we rearrange that and we get cos 2x plus 1 all halved. If you times that by 4, you get 2 of them. So that's going to be 2 cos 2x plus 1 plus 2, I should say. And then this one integrates. I'm having a really good time right now, laughing in my head about just how much people were screaming at me for the last I don't know how much time I've burned trying to do something with this, but seriously, not just the fact that I didn't just expand that and immediately write down the exceedingly obvious answer that you get is really funny. So yeah, good times. That's I was really annoyed at myself, and I am still really annoyed at myself. But the fact that that will have pissed a lot of people off who are watching does make me feel slightly good. 448 is the last one that I'll do today, and it looks kind of cool. I imagine, based on how terrible I am, that I probably won't get it, but hopefully, I've already forgotten what it is, of course. 8x and then a log of something. But what is it the log of 2x plus 1? Okay, so dx. Ooh, cool. So, parts then. Seems obvious because it's two things multiplying. The 8s can go out here. We don't really need it, so let's just do it anyway. So I imagine Dr. Malice put that in to be nice. Maybe there's something good about it, but let's just ignore it. Now, parts could work here. I know the integral of this, so I could use that. I don't think it'd be helpful. I think it's more obvious to try and differentiate that business there. So let's do that. So let's integrate the x a couple of times and just make it, if I do this maybe, x squared over 2 and then leave the other one alone. And then we'll take away the integral of, again, x squared over 2, which I could put the over 2 outside, but it doesn't really matter. A shame that we're going to just do another integral by parts here. Oh, sorry, and then I have to actually differentiate this, which is, of course, 2, which will cancel this, 2x plus 1. Okay. Now, does this integral seem easy to do? Well, it surely isn't that hard, right? How hard can it be? Really, how hard can it be? So, could you consider doing more parts? I mean, is it not? No, it's not. I was going to say, is it not similar to the other one we did by parts, but the power -1 kind of screws you over there. Okay, so it's not that. could you just could you make a substitution? I guess there should be a dx there as well. Like a substitution u equals 2x plus 1 would seem like a logical thing to do, because x squared is something that I can just evaluate, right? It's u minus 1. Let's just say 4x squared is this. That might make it a bit easier, because then I could just like, I mean, we could expand this out, right? And put an 8 here. And the reason I'm doing that is just because what just happened there? It's just because I'm going to be really lazy here and just put a 4 here and a 2 there, because that way I can substitute this without any effort. Dx is obviously 2, sorry, du is 2 dx, so we can need a half out here, which actually cancels that 2, which is very pleasant. And you see why Dr. Malus put the 8 in front, I think, which is cool. And then this is u minus 1, and this is just u. Okay, and this turns into the same kind of integral that we have seen before plenty of times, I'm sure. This is just u minus 1 over u. Is this actually the same as the first one we did now? Pretty much. So the integral of 1 is x, or sorry, is u really. And the integral of that is, well, it's actually x plus, isn't it, log u. And then, of course, we can just replace the u object, and we should have something of the form answer. I'm still feeling it. We haven't really done a particularly tricky one that I haven't really, oh, well, I mean, I found them tricky because I'm an idiot, but we haven't done an amazingly hard one, so I think we've got time for one more. 394. 394. Let me check that was the right number. Yeah, cool. Oh, this looks cool. Immediately. Fun. Some good stuff that I can just see there. Let's do it. Delete, delete. E to the cos x, sin x, cos x. Looks fun. E to the cos x. And then down here, sin x, cos x. Cool. And this 8 doesn't exist here, I don't think. Okay. Cool. So sin x cos x is the double angle thing. I don't know how relevant that's going to be right now. What could be relevant is if you put the sign here, like this is now just integrable, and just makes an e to the cos x. I guess there's a minus in front as well. And that's cool because it makes me think parts could work here. Maybe. Also, could you not just make a substitution here on that basis as well? Because if you made a substitution, we sort of skirted around this. Was it the first one we did that I was being, or the second one where all I had to do was expand the stupid object and get it right? Du is sin x dx, and so that will cancel the sign. I think this is probably the intended way of doing it, right? So this is e to the u, and then this is a u, and then the sin x's cancel. Okay, so this is just how you do it. Good. So this is now quite a trivial integral to do. We're going to do yet another round of parts, I guess. Obviously integrate e to the u because I want to differentiate u. This is, if I'm in my prime, this is an integral I think I can just write down the answer to, because it's this when you differentiate the u and then you integrate that and you just get e to the u. So it's just this. Good. Yeah, and then you can put the u back here, and you end up with this. And then, of course, you can check, does this work? When you differentiate this, you get a minus. Ooh, the minus messes us up because there should be a minus there. Always check your answer, mate. Okay, how does that actually make a difference? It just puts a minus in front of this, right? Which puts a minus in front of your whole answer. So it's just this. Let's check that. So differentiate sign cancels that out. Differentiate this object, you get the sine bit. So it ends up looking like a minus sine x e to the cos x, and then that's also a minus sine x e to the cos x. So that ends up taking away 2 of them. So actually, should that be a minus as well? Why would that? Because the second one should have been a plus. Is that why that works? Hang on. So yeah, when you differentiate this object, you get minus sine. These cancel. And that just gives you this object. And then when you differentiate that bit of it instead, you get a minus. Oh, the 2 minuses cancel, sorry. You get a minus sign from differentiating this, which makes it a plus. And then when you differentiate that, then it cancels, so that's fine. Okay, so we arrive at the answer, and thus ends a video of terrible integration, where I imagine the people playing along got everything much faster than I did. But cool, that's how it goes. Thank you for watching, and maybe I'll make another one of these at some point.